Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will do some questions on definite integrals as the limit of a sum. But let us first go through these results. Summation r running from 0 to n minus 1 k is equal to k times n minus 1. Summation r running from 0 to n minus 1 r is equal to n into n minus 1 divided by 2. Summation r running from 0 to n minus 1 r square is equal to n into n minus 1 into 2n minus 1 divided by 6. Now let us evaluate a definite integral from the definition of definite integrals as the limit of a sum. In this definite integral, integral a to b x dx, we have fx equal to x. Also, nh is equal to b minus a, that is upper limit minus lower limit, and we can write f of a plus rh. So we have to replace x by a plus rh, that is equal to a plus rh. Okay, now from definition of definite integral as the limit of a sum, we can write integral a to b fx dx is equal to limit h tends to 0 h times summation r running from 0 to n minus 1 f of a plus rh, or that is equal to limit h tends to 0 h times summation r running from 0 to n minus 1. Instead of f of a plus rh, we have a plus rh. It is a plus rh. That is further equal to its limit h tends to 0 h times summation r running from 0 to n minus 1 a. Then we have plus, we put back bracket here, so then we have plus, it is h into h, that is h square summation r running from 0 to n minus 1 r. We can write h outside this summation because it is free of r. Now this is further equal to, it is limit h tends to 0 h times, and this is equal to the summation r running from 0 to n minus 1 a. This is equal to a into n minus 1. Then we have plus h square. Now we have summation r running from 0 to n minus 1 r. This is equal to n into n minus 1 divided by 2. Okay, or we can write it as it is equal to limit h tends to 0, it is a into nh minus h plus, then we have n into h and n into h minus h. Now we can multiply 1h to this factor and 1h to this factor, so we get nh into nh minus h divided by 2. Okay, Now this is further equal to limit h tends to 0 a times. Now here we have nh, and instead of nh we can write b minus a. So we replace nh with b minus a. It is b minus a. Then we have minus h. Then plus, again we have nh, so we write b minus a. Then again nh, it is b minus a minus h divided by 2. Okay. Now apply the limit h tends to 0, we get a times b minus a, h becomes 0, then we have plus b minus a into b minus a divided by 2. Okay, that is further equal to, now we can take b minus a common, so we get b minus a into a plus b minus a divided by 2. That is further equal to, it is b minus a into, it is 2a plus b minus a, 2a plus b minus a divided by 2. That is further equal to, it is b minus a into 2a minus a is a, so we get a plus b or b plus a, so it is b plus a divided by 2. Now b minus a into b plus a is equal to b square minus a square divided by 2. So that is the value of this definite integral. So integral a to b x dx is equal to b square minus a square divided by 2. That completes the question. Now let's evaluate one more definite integral. In this definite integral, integral 2 to 3 x square dx, we have fx equal to x square and nh is equal to upper limit, that is 3, minus lower limit, that is 2, which is equal to 1. Okay. Also, f of a plus rh, where a is lower limit, in this case it is 2, so we can write f of 2 plus rh. Now we replace x by 2 plus rh, so we get, it is 2 plus rh square. That is further equal to, it is 2 square equal to 4 plus twice ab, that's 2 into rh, so it is 4 rh plus b square, that is r square h square, r square h square. Okay. Now from the definition of definite integral, as the limit of a sum, we have integral 2 to 3 x square dx equal to limit h tends to 0 h times summation r running from 0 to n minus 1 f of a plus rh, that is equal to limit h tends to 0 h times summation r running from 0 to n minus 1 Now instead of f of a plus rh we have 4 plus 4rh plus r square h square. Okay. Now that is further equal to limit h tends to 0 h times summation r running from 0 to n minus 1 4, then plus we have h into h, that's h square, so we can write 4h square 4h square summation r running from 0 to n minus 1 r, then again plus it is h into h square, that's equal to h cube summation r running from 0 to n minus 1 r square. Okay, now that is further equal to, it is limit h tends to 0 h times r summation r running from 0 to n minus 1 4, this is equal to 4 times n minus 1, then we have plus 4h square summation r running from 0 to n minus 1 r, this is equal to n into n minus 1 divided by 2, then we have plus h cube it is summation r running from 0 to n minus 1 r square, this is equal to n into n minus 1 into 2n minus 1 divided by 6. Okay, it is further equal to, it is limit h tends to 0, then we have 4 times nh minus h plus 4 times, here we have h square, so we multiply one factor of h to this n and one factor of h to this n minus 1, so we get nh into nh minus h divided by 2, then we have plus, here we have h cubed, so multiply one factor to this n, one factor to n minus 1 and one factor to 2n minus 1, so we get nh into nh minus h into 2nh minus 1, sorry, 2nh minus h divided by 6. Now we replace nh by 1 as nh is equal to 1, so we get the limit h tends to 0 4 times, instead of nh we have 1, so it is 1 minus h plus 4 into 1 into 1 minus h plus 1 into 1 minus h into 2 into 1, that's 2 minus h divided by 6. Here it is divided by 2. Now applying the limit h tends to 0, we get, it is 4 into 1 minus 0, so that is equal to 4 plus 4 into 1 into 1, that is 4 divided by 2, plus it is h is 0 and this h is also 0, so we get 2 into 1 into 1, that's 2 divided by 6, which is equal to, it is 4 plus 2 plus 1 by 3, or that is further equal to, it is 4 into 3, that is 12, plus 3 into 2, that is 6, plus 1 divided by 3. it is 19. So we get 19 divided by 3. Thus, value of this definite integral 2 to 3 x square dx is equal to 19 divided by 3. That completes the question. Now, in my next lecture, I will continue this topic. Till then, take care of yourself. Thank you.